Okay, on the CAASSP test, there are several geometry questions. And just to refresh on the geometric shapes and how we calculate perimeter and area. For a circle with radius r, the perimeter is 2 times pi times r, the radius. The area is pi r squared. For a square, the perimeter is 4 times the one side length a, and the area is a squared. For a rectangle with width and length w and l, the perimeter is 2w plus 2l, and the area is w times l. You already know all that. Now we're going to get into some things that are a little more memory intensive. So for a triangle where we have 3 sides, a, b, and h, the perimeter is a plus b plus h. The area is 1/2 b times h. For a trapezoid, where we have 2 parallel sides and 2 sides that slope at the same angle, where the side lengths are a, b, and c, so the 2 parallel sides are a and c, and the 2 sloped sides are b, that's called a trapezoid. For a trapezoid, the perimeter is a plus 2b plus c. The area of a trapezoid can be thought of as the area of a rectangle plus 2 triangles. So we have the rectangle that's described by a and h, that's the area of that rectangle, and then we have the area of the 2 triangles, which is going to be c minus a, the long side minus the short side, times h, which is the height of this. This is really the area of 2 triangles added together. For a rhombus, which is a square that's pushed over so that we have 2 sides parallel and then 2 sides parallel, but this angle is no longer 90 degrees, the perimeter of a rhombus is 2 times a plus b, and the area of the rhombus is b times h, where h is the height of the rhombus taken from the vertex of this angle to perpendicular to the opposite side. So the area of a rhombus is b times h. Now, a regular polygon is a polygon, that means a multi-sided figure that has all of the sides the same length. In this case, I've got a pentagon shown because it has 5 sides. Penta means 5. If I had 6 sides, it would be a hexagon. If I had 7 sides, it would be a septagon. If I have 8 sides, it's an octagon. And when I look at these regular polygons, the perimeter is always going to be the number of sides times the length of the side A. They're regular polygons, so all the sides are the same length. The area of a polygon is 1/2 the number of sides times the side length. So once again, the area of a polygon is 1/2 the number of sides times the side length. Okay, on the CAASSP test, they're going to be asking questions having to do with transformations. Transformations are when we're moving or changing an object that's already existing in our representation of space. So in this case, I have a rectangle. A translation is the movement of a shape from one position to another. I can have a horizontal translation in combination with a vertical translation. All that means is we're moving it on the coordinate plane, and this translation moves the object to a new location, but it does not change the size of the object or the orientation of the object. So in this case, wherever I move to, the rectangle will still be oriented in the same position. If we want to change the orientation of the object so that I take my rectangle and turn it into this, that would be called a rotation. A rotation is where we're changing the orientation of the object with respect to the x and y axis, and that rotation can occur in a clockwise fashion, moving to the right around or in a counterclockwise fashion, and would normally be defined as how many degrees of rotation we went through in changing the orientation of this object. In this case, I rotated the object 90 degrees. Now, the third kind of transformation that we can undergo is we can undergo a transformation called a dilation. Dilation. Just like when the eye doctor dilates your eyes to change the size of your pupils, a dilation in the transformation world is I've changed the size of an object. So the dilation will be defined by a scale factor. In this case, it looks like I had a dilation of about 2 times to the size of the rectangle from here to here. So the 3 possible things that go on in a transformation is number 1, translation, where we're moving the placement of the object. Number 2, a rotation, where we're changing its orientation with respect to the X and Y axis. And number 3 is a dilation, where we're changing its size by some dilation factor, which can be a multiple, making it bigger. It can be a fraction, making it smaller. Within the field of geometry, we talk about parallel lines. Parallel lines have the characteristic that they never contain any points in common, and they never intersect each other. So that's the definition of parallel. No points in common, no points in common, and they never intersect. Okay, so that's parallel lines. When we have a line that bisects a pair of parallel lines at some angle, so here I've got a line that bisects these green lines that are in parallel, we can look at this and we know certain things are true. We know that because these 2 lines are parallel, that this angle 1 is the same as this angle. We'll call this 2. And that this angle here, which we'll call 3, is the same angle as this angle 4. And that 2 prime is the same as 2. And 1 prime is the same as 1. 4 prime is the same as 4. And 3 prime is the same as 3. Because the lines are parallel, they have common angles for the bisector that goes through both lines. All right, within the thought of geometry, we have some special shapes. And this special shape is called a right triangle because it has an included angle of 90 degrees. All right, right triangles have special characteristics that we make use of all the time. But primarily, when we're talking about right triangles, we can figure out what the length of any one of the sides is if we know the other 2. So if we have 2 known sides, we can find the length of the 3rd side. And the reason is that the side lengths are related as follows, and this is the Pythagorean theorem. Guy back in Greek times came up with it by the name of Pythagoras. So if we know A and B and C, this is what's true, is A squared plus B squared equals C squared. So if I know A and B, I can calculate C. If I know B and C, I can calculate A because I can say, look, we'll start with A and B. We know A and B. I can go A squared plus B squared and take the square root of that, and that is equal to C. If I know C and B but not A, I can go the square root of C squared minus b squared equals a. If I know a and c, I can go the square root of c squared minus a squared equals b. So we can always find the length of an unknown side of a right triangle by using the Pythagorean theorem. All right, on the CAASSP test, they expect you to know how to calculate the area, the surface area, and the volume of some of the standard shapes that we deal with on a regular basis. So let's go through these one at a time. A cube is just like a die. It's the same length on all of the sides, and so the surface area is 6a squared, because there are 6 sides and the surface area of one side is a squared. The volume of a cube is a cubed, all right? Whenever we look at volumes, we have to end up with some length times some length times some length, length cubed. For a sphere, the surface area of a sphere is 4 pi r squared, all right? So the surface area of a sphere, and the volume of a sphere is 4/3 pi r cubed, right? A prism is a rectangle that's stretched out to make it long. So we've got the rectangle length and width and height. So the area of the rectangle is going to be 2 times the regular rectangle plus 2 times the height times the width plus the length. So we've got the base and top, and then we have the 4 sides that we're accounting for. And we just took that rectangle and stretched it out. So the length times the width is the area of the base of the prism times the height gives us the volume of the prism. For a cone, the surface area is going to be comprised of the area of the bottom, which is the area of a circle, plus the area of the surface, which is pi r times h. So the area of the base plus the area of the cone, which is pi r h, and the volume of the cone is 1/3 pi r squared times the height. Think about this. In this case of the pyramid, it's 1/3. Just remember that. Cones and pyramids are 1/3 the base times the height. So in this case, for a cone, which is a circular solid, it's 1/3 pi r squared times h. For the pyramid, we're going to have the area of this pyramid comprised of the base plus 3 triangles. So the base is a times b. The 4 triangles are 1/2 h times 2a plus 2b. And the volume of that pyramid is 1/3 the base, a times b, times h, how tall the pyramid is. Once again, review these. You're expected for the CAASSP test to know how to do these shapes at the very least.